Click, 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 click. And we are live. If you guys are just joining us, if you're in the Discord chat and you're watching this live, then you know what's going on. I'm running a little bit late due to weather, but if you are watching this later, yeah, I was swinging it into the house last minute, so I am gonna like literally go live and then walk off camera to go grab a drink. Oh Lord. All right, how is everybody doing tonight? Fantastic, I hope. It's been an eventful week with Corey in town and Tommy and man, goodness, it's been just head spinningly quick trying to keep up with everything. So today, the plan that I told you guys last week was that we were going to do aeronautical decision making and crew resource management and probably physiology this week. If you notice from the title and from my cover photo, that is not what we're doing this week. The main reason is I wanted to spend a little bit more time really focusing on that one and making that one just really good. And so I'm putting together a PowerPoint presentation for this entire course. So when I run through it the next time, I'm going to use a PowerPoint instead of all of the web browser tabs. So I'm going to use next week to do the crew resource management, aeronautical decision making, and physiology all on the PowerPoint system and make that the one public stream of the month, because I also feel like it's going to be the more interesting, and it's like basically this stream and the next stream, and then we've covered all of the material one time through. And I guess I will do. I'm still looking into the waiver situation. I was just talking to somebody on the phone today about what is involved on some of the other waivers, and apparently your nighttime Whoa, God, cat. Okay. What is... That's not normal. All right, get down, kiddo. They're being a little bit weird today because my roommate Mike is watching his parents' dog, which is just like a little teeny tiny Yorkie. Like it's the same size as the cats, but they're just a little bit more on edge than normal. So anyways, next week we're going to do that, and that will be the end of the 107 Airman Certification Standards and all of the stuff that you'll need to know for your written. We will throw in a waiver application as well. I think it's what we're going to do is probably... I don't know. I'm still like looking into it. I think the next easiest one after nighttime waiver, maybe I'll just show the nighttime waiver application process again, because it looks like every other waiver is a lot more involved. Like the next easiest one is the operations over people, but it is way more involved than the nighttime waiver was. So nighttime waiver you can pretty much knock out in an afternoon, in the course of a stream, like an hour-long application. What's going on, Monkey? Good to have you in here, homie.
Yeah. So, how are you, man?
Doing fantastic. Doing fantastic.
Good.
So,
You keep getting thinner.
not this last weekend. Holy cow! I think I put on like 5 pounds with you
Too
guys
much
being in
tacos.
town. Yeah, too many tacos and too much good times. Quite frankly, not that that is a bad thing. Not that that is a bad thing at all.
Yeah, they were.
So, all right. Well, with that being said, we're going to dive right on in. If you have been here before, then you know where we start, which is on. Oh, come on. Give me the. Let's do this. Over here on Airman Certification Standards, because all of the FAA certifications start out with the Airman Certification Standards, which is basically our outline of the things that you need to know to get your Part 107 certificate. I hadn't fixed any of my stuff, like my Chair height was still set up from Call of Duty earlier today. Oh Lord. Okay, so we're just going to scroll down here. This is an outline of all of the knowledge that you should have in order to get a 100% on your Part 107 written exam. So we've already gone over regulations, airspace, airspace classification, weather, and we're getting in to the last. This week's stream is going to be a lot less structured than the other because the content here is kind of like the miscellaneous. Yes, it does have its own section, but the FAA, as I'm going to show you here, has given us very, very little to go on information-wise about the loading and performance and maintenance and also emergency procedures. So we're just going to talk best practices in terms of industry-wide in aviation for the most part here. We will be referencing the Advisory Circular 107-2. It also references the Airman's Manual. I think I got that over here on one of these other tabs. But actually, no, I closed it out because it was literally nothing pertaining to the 107 stuff on these aspects. So let's talk about, first and foremost, is going to be the loading and performance. It says here, applicant demonstrates understanding of general loading and performance, effects of loading changes, balance, stability, and center of gravity, and the importance and use of data to calculate the effects of aircraft performance on a UAS. Okay, so we're going to go over here to the Advisory Circular 107-2 and look at what it has to say about weight and balance because it's pretty minimal. For full-scale aircraft, weight and balance is it's important for the UAS as well, but typically on full scale, you'll have an operating manual for the specific aircraft that you're flying that has data points where you not only have numbers telling you what the maximum weight at takeoff is, the maximum weight at landing is, the maximum range. Like you get a lot of information about the weight and balance and performance of the aircraft. They'll also tell you the arm or moment of each position. They'll say because you calculate the weight and balance, you would calculate the center of gravity and make sure that it falls within the operating range of that aircraft. And so you do that by taking the weight of, like, say, the pilot and multiplying it by the arm, which is a distance from a datum plane. Typically, they use the propeller or some point in front of the propeller, and so that calculates the if you ever take physics and they talk about the arm. So if my arm can only pivot at the elbow, the arm or moment would be the distance from that pivot point. And so you multiply those two and then you divide the ultimate. It doesn't really matter because you're not going to be calculating it for any of these. But for the UAS, it's pretty simple and straightforward. So let's just look at what it says here. It just says, before any flight, the remote PIC should verify the aircraft is correctly loaded by determining the weight and balance of the aircraft. An aircraft's weight and balance restrictions established by the manufacturer or builder. Guess what? For FPV, we are the builder, so we get to say what the restrictions are. An aircraft's weight and balance established by the manufacturer or builder should be closely followed. Compliance within the manufacturer's weight and balance limits is critical to flight safety. The remote PIC must consider the consequences of an overweight aircraft if an emergency condition arises. All right, so it says also, even though a max gross weight may be specified, the aircraft may not always safely take off with this load under all conditions. This is like if you go to altitude. Monkeys experienced this flying at like 13,000 feet before. Your aircraft is not going to perform as well at those higher altitudes. You might want to think about maybe not running a Hero 8 and instead of running a Session in that scenario, or maybe running 5S on your 4S setup in order to get higher RPMs, more thrust, and get back to the same types of performance. They also bring up the point that weight changes during flight have a direct effect on an aircraft's performance. One of the big ones being fuel burn. If you're talking about a gas-powered UAS, which we don't typically fly, our fuel is lithium or lipos, and they don't get any lighter as you suck the electricity out of them, unfortunately. They also go over a little bit about the balance and stability around the center of gravity. Adverse balance conditions, i.e., weight distribution, may affect the flight characteristics in much the same manner as those mentioned for an excess weight condition. Basically, if your center of gravity is far enough off, then you're not going to be able to compensate. Like, for instance, if you were to say, hey, I want to fly a 360 cam, but I want it 2 feet out in front of the drone so that it gets a really cool shot. Well, you would want to balance your aircraft, because if you, let me see if I got a quad around here. I'm sure that I do. Actually, I may not. I sure don't. I got one in the living room. Hang on. Okay. So, if you were to mount a 360 camera on a stick that you strap to the bottom of the drone, and so the 360 camera is way out here, you would want to balance the craft and make sure that the center of mass, because I'm saying that if it's like 3 feet out or 4 feet out, if your center of gravity becomes a point outside of these four motors, then the motors wouldn't be able to compensate no matter what, because all they would be doing is rotating the whole contraption around some center of mass that's further in front of the craft than they are able to exert a force. So that would be something that you would want to take into consideration, due to the fact that in FPV, we are 99% of the time the builder. Nobody is going to be providing you with performance data. It's going to be up to you and your experience to make sure that you don't load down your drone with more weight than it can handle, and that you load it in such a way that the center of gravity is close enough to the center of your props, your motors. Ideally, you want the tail down, and so having a slightly forward center of mass on a quad that is almost always in forward flight makes sense. Now, if you're doing a bunch of cricket stuff and going backwards and doing all this stuff, and really, for 90% of mini quad people, the center of mass being center of gravity being the same as the center of mass is a good thing. And when I say so, center, oh man, we don't need to get into exactly what the difference is. The center of the physical dimensions of the quad, you want your center of gravity to be as close to that as possible. All right, let's keep going on. Yeah, as it also goes in and talks about the center of gravity can shift during flight if you are moving a variable load. An instance of that would be if you had retractable landing gear and the gear went back, that would change your center of mass. Another example is if you had a payload, like a camera that you maybe want to get out to one side of the craft or another, and it's on like a articulating arm, that can be a consideration to take into. All right. That is going to just about cover it, because that's the only guidance that they give us on weight and balance here. Let's just look up real quick in the if you want to get a good source of information about weight and balance on full-scale aircraft and what it looks like, you can come over here to the pilots. All I did was copy the reference, the number, which gives us the Pilot's Handbook of Aeronautical Knowledge, and weight and balance and aircraft performance. And this is going to go a lot more in depth on explaining the arm and moment and how shifting weights can cause shifts. The questions that we will get on the 107 related to this are pretty simple. This is going to be a lot more in depth. You can see that on this thing here, we've got a 50-pound weight with a 50-inch moment, 100-pound with a 25-inch, and it's balancing out by one 50-pound weight that's way further away from the fulcrum. That's just kind of illustrating how they calculate it, the full-scale planes, center of gravity, etc. One of these days, they will end up incorporating some form of weight and balance requirements for drones, I assume. But it's pretty basic at this point. Okay. Also, at the end of tonight's stream, I'm going to make a lot more time for practice tests as well as question and answers. So if you guys have come up with any questions in the past weeks, this would be a great opportunity tonight. We went over radio communications and airport operations last week. Now we come to emergency procedures. Now, one of the big things that they talk about here is our lipos and characteristics and potential hazards of lithium batteries. These SAFO are all documents having to do with the safe carriage of lithium batteries in checked baggage in airlines. Like, I guess they just assume that drone pilots are going to be flying with lipos because there's nothing like these. Um, I don't even know. Safety alert for operators. This is stuff for Part 121 operators. I have no idea why it's being referenced in the 107 airman certification standards because these are documents that should be aimed at like Delta and United about creating policies for the safe carriage of lipos. It's good information to know. It's basically saying that you can't check your lipo batteries. Your lipo batteries need to be in your carry-on bags. They need to be individually packaged so that you're not shorting batteries out. I know that I'm guilty of not doing that. I just chuck all my lipos in. The TSA agents don't know any better. The airline doesn't check it. But technically speaking, you should be putting. You could even put each battery in a prop bag, or if you had caps to put on the XT60 and the balance lead, then I would say that that would suffice for individual packaging. See, it goes into during the ticketing and purchase phase, you should advise the passengers of this. So this is all stuff aimed at the airlines. I just kind of brought it up to show you the limited guidance that they really give you on this, and that's these three documents. Here, those are yeah. So that was the balance and stability section. I already got that one. This one for the 107 advisory circular, all they give you about battery fires in here is lithium-based batteries are highly flammable and capable of ignition. A battery fire could cause an in-flight emergency, causing loss of control of the small unmanned aircraft. Lithium battery fires can be caused when a battery short circuits, is improperly charged, is heated to extreme temperatures, or is damaged as a result of a crash, mishandled, or simply defective. So they're just acknowledging here that lipos are dangerous. One of the things that they do talk about is that right here is safe charging, safe usage, and risks of fire involving lithium batteries. So I'm going to take a second just to kind of talk about best practices with your LiPo batteries, so that I can say that I have passed on the best knowledge that I have. Number one, always use your LiPo fire safe bags. Now I know that in practice it's probably going to do next to nothing to save you in a real emergency situation, because what happens is a lipo fire is actually a chemical reaction. It's a thermal runaway where the lithium polymer gets so hot that it creates a chemical reaction that looks like fire, and it goes on and it will ignite the next cell and the next cell and the next cell. If you've ever seen a lipo actually go up, it pops and there's a lot of smoke, and then typically it'll look like it's out for a second, and then the next cell will pop, and then there's a lot of smoke, maybe even a flame. I've seen it. It looks like a flamethrower. It's freaking terrifying when it really happens. And if that happens in your lipo bag, what's going to happen is it's just going to keep lighting cell after cell after cell after cell. So ideally, you would keep your lipos in like your garage, on concrete, somewhere safe, because they can go up in the middle of the night. It's not that likely that it's going to happen. If they're going to blow, it's most likely going to happen while it's on the charger. So don't ever, ever, ever put your batteries on the charger and go to the store or leave the house for any reason. Stay home with them. Don't go hop in the shower. Don't just be available so that if something pops off, you're able to react. I've only been there when a battery went up on the charger one time, and we were at like an ice hockey rink, and luckily the whole thing was on a concrete floor, but it was shooting flames out of the thing like this freaking long, and I just instinctively ran over and started pulling it to get that battery off of the balance charger so that it wouldn't light like 4 more batteries off, because it was dangerous. And as a matter of fact, Monkey can even attest to this because he was crashing with me last week. I have a fire extinguisher right next to my charging station. And the fire extinguisher is not for the batteries. You can't put out the battery with a fire extinguisher. The only thing you can do is to cool it off to prevent that thermal runaway. Airlines are trained, if they have a lipo fire, what they do is they take a bin of ice and they put the battery in the bin of ice, because that cools down the battery and helps prevent more cells from popping off. And if you're ever on a plane and you see smoke from your bag and you know it's lipos, get that thing out. Get the like it's gonna suck. You might get a little bit of burn on your hands, but you gotta do that, because otherwise it's gonna keep filling the cabin with smoke and it's gonna be a real emergency situation for the crew to deal with. So yeah, be safe. Monitor your batteries when charging. Don't leave them charging and unattended. In terms of flying, I get asked this a lot. When do you say a battery is no longer safe to charge and fly? I am on the. I know some guys that are like, if it's got a dent, I'm not flying it. I'm too hard on my gear. I can't make that determination where if it dings up, I'm gonna toss it. However, if not the wrapper, because they're wrapped in heat shrink, and then inside of that there is like a metal looking wrapper on each individual cell. If that is broken to where you can see the individual layers within that, if that metal wrapping on the 4 or 5 or 6 cells is broken, then do not charge that battery, period. If that's broken. Now, number two, if it's dented, what I will do, almost all battery chargers these days have the ability to check internal resistance. Now, the internal resistance is how much electrical resistance that battery has to taking a charge or discharging. Okay, every battery has it some level of internal resistance. Better, more expensive batteries have less than cheaper batteries typically, and every battery throughout its life is going to get higher and higher and higher internal resistance. So I periodically check all of my batteries' internal resistance. Be familiar with that function on your charger, and check your batteries when they're new or when you change brands, so that you know what you should typically see for a given battery throughout its life. Like maybe it starts where every cell is like at 3 milliohms of internal resistance, and when it's about time to retire, it's at 15 or 20. That's kind of where I am with most of my batteries. And so if I have one that I've crashed and it's got a dent in it, but nothing broken, like the wrapper around the individual cells is not broken, I'll put it on the battery charger, do an internal resistance check, and if none of the cells are up above that 20 milliohm range for me, then I keep charging it. I'll keep an eye on it when I charge it, just in case something were to go wrong, but that's usually a fairly good indicator that it is not going to, catch fire. Now, if I put it on there and do an internal resistance test and it's like 40 or 50 or 60 or 30 or anything outside of my normal range of somewhere between low single digits to the 20 milliohm on my charger, every charger measures it differently, so it's important to know what you should expect to see by testing healthy batteries. If it's outside of that range, then I'll just go ahead and retire it, because it's not worth burning down my house over. Okay, so we talked a little bit about safe charging, safe usage, transportation, inspection and handling, risks of fire, and we have gone way above and beyond even the references that the FAA gives on this. So, another thing to talk about is loss of control link and flyaways. If you remember about when do you have to report an accident to the FAA? Does anybody remember this? Anytime that the property damage exceeds $500, or anytime that there is serious personal injury. Typically, the easiest way to say is if there's loss of consciousness, or injuries that require hospitalization. Those would be considered serious injuries, in which case you have to report to the FAA. The one other weird one is the NTSB requires reporting for loss for a flyaway. Now, not loss of control link, because a loss of control link would be a failsafe, but as long as the craft performs in the same way that you would expect it to, meaning for us, typically we program our quads to, if you have a loss of control link, that it just dead ducks, falls out of the sky, the props stop moving. Uh, that wouldn't be considered a flyaway because it's following the protocols that you've set forth in the failsafe. But with a flyaway, that would require a report to the NTSB. Okay. Uh, let's see. And yeah, loss of control link can happen because that's going to bring us down to the frequency spectrum and associated limitations. Um, let's just go ahead and jump into that because that was the next thing up in the 107 here. So UAS frequency utilization, right here they just acknowledge that most quads most drones for that matter, use the 2.4 gigahertz and 5.8 bands. If you guys have been flying FPV, you're well familiar with it. They've got it backwards here. It's funny, I just noticed this today. It says, yeah, many modern UAS use 5.8 systems to control the aircraft and 2.4 to transmit video. We actually do the exact opposite typically, although a lot of guys these days are using the 900 megahertz through Crossfire or the R9s. Etc. in order to use the control link. But, RF has limitations, especially 2.4 and 5.8. Those are strictly line of sight. They go into that both of those are not considered to be penetrating. 900 megahertz and lower, those frequencies are used to penetrate, but with Part 107, we have those line of sight requirements, and that's partly baked in for the RF considerations on their part. Yeah, and they just acknowledge here that the 5.8 and 2.4 are also used for Wi-Fi and a lot of consumer electronics, and so flying in dense housing or office buildings, there may be many routers, things on those frequencies that could cause lots of interference, which could then result in these loss of control links or flyaways. Another thing to consider is if you are using a GPS on your drone, that you should probably be programming in fail-safes specific to the GPS. So if you're building craft for Part 107 operations, that maybe it's not a FPV drone, maybe it's something to inspect pipelines and it's got a GPS on it, and you're like, okay, if I lose control link, I want you to then return to home or whatever it is, just like with your Mavics and your DJI products, you might want to consider having a fail-safe protocol that is if the GPS fails, because you could have a GPS failure and a controlling failure in the same time, in which case it may be prudent to do a different fail-safe protocol. Yeah, because it wouldn't know where the return to home is. You might want to have something scripted so that it requires a specific number of satellites before it's going to execute a return to home. That way it doesn't, fly back to China. So, all right, I think that about covers it for our emergency procedures sections. And aeronautical decision making. That'll be next week along with physiology. We're going to jump down here to maintenance and inspection procedures. Now, this is another one where there's just not a ton of information. A lot of this has to do with the nature of FPV as a hobby, because we're kind of in this weird space. Like, most of the 107 regulations are written from the perspective that you would fly in such a way as to never crash, whereas we fly in such a way as to crash a lot and improve ourselves as a pilot. This is written a lot to rely on the technology. I feel like FPV kind of butts heads with 107 regulations a little bit, but I try to teach this course from a happy medium perspective. So let's go ahead and look at what the 107 advisory circular has to say about maintenance. Here we go. So it's one of the first things in here, or maybe I'm just like Oh no, this is the whole maintenance section. My bad. So they acknowledge that aircraft maintenance in general, whether we're talking about unmanned systems or full scale, includes two types of maintenance: scheduled and unscheduled maintenance. Now, scheduled maintenance would be maintenance that is outlined by a manufacturer and is given the guidelines of when that you would perform certain things. For instance, like full scale planes, if you buy a Lycoming engine, they have a time between overhaul that's stated. So every 100 hours or 200 hours, you have to go in and there's a list of things that have to be done and replaced and either replaced or inspected on the engine. Maybe you have to inspect it, and then if it doesn't fall within these parameters, then it has to be replaced. Or maybe you just go ahead and replace it. But these are scheduled maintenance items that are outlined by the manufacturer. So as you can see here, the scheduled maintenance section, the UAS manufacturer may provide documentation for scheduled maintenance of the entire unmanned aircraft and associated system equipment. There may be components that are identified by the manufacturer to undergo periodic maintenance or replacement. But this is the section that more applies to us because we build our own stuff. If there are no scheduled maintenance instructions provided by the UAS manufacturer or component manufacturer, the operator should establish a scheduled maintenance protocol. This could be done by documenting any repair, modification, overhaul, or replacement of a system component resulting from normal flight operations and recording the time in service for that component at the time of the maintenance procedure. Over time, the operator should then be able to establish a reliable maintenance schedule for the SUAS and its components. And this is kind of where we break down with the system because our operations are not normal. I have never had I've had so few components that just failed from normal operation that there's no way that I could establish personally, and I've been doing this for years, a scheduled maintenance for my craft. So all of my maintenance falls into the unscheduled maintenance category. Yeah, like I'm thinking about individual. Like I just had to replace a nano receiver, and oh, actually that was the 5-volt regulator on the flight controller. But it went bad because I crashed in water. like that's the thing, is that none of this stuff really goes bad due to normal procedures. So I have found that through my documentation, I am unable to establish a maintenance schedule that is adequate to the needs of the craft that I build. Plus, like every freaking 2 months, I need to have all new gear because everything is outdated and replaced. Okay, so let's get into our unscheduled maintenance. During the course of a pre-flight inspection, the remote PIC may discover that a UAS component is in need of servicing, lubrication, repair, modification, or overhaul, or replacement outside of the scheduled maintenance period as a result of normal operations, or resulting from a mishap, a crash. In addition, the UAS manufacturer or component manufacturer may require an unscheduled system software update to correct a problem. So this is just saying that you need to be inspecting your aircraft prior to every operation. That brings us to our pre-flight inspection section here. Oops, not this one. We're done with that one. Before each flight, the remote PIC must inspect the UAS to ensure that it is in a condition for safe operation. Mainly, our inspections should be for damage or malfunctions. Whenever I'm gonna go fly, I always look and make sure that there's no obvious like wires that are coming out of the thing that have gotten chopped or broken in a crash. When I plug in for the first time, I verify that I have video, that the video is good, the camera is working, it appears to be operating with the video transmitter at the power that I expect it to be at, and on the proper channels, etc. So if I've got good video, I'll then arm the drone. Where's that one that I had set up? Here we go. One thing that I like to do is set it on the ground, you arm it, make sure all 4 motors are spinning before you put the goggles back on. So all the motors spin, yep, we're good to go. And if I've done any maintenance or it's the first flight of the day, I will arm it and then not raise the throttle, but use the pitch stick to lift the tail, lift the nose, lift the right, lift the left. That makes sure that all the motors are still spinning in the right direction. All of them are carrying enough current, because I've also had situations where, like an ESC, as soon as you put it under load, would cause it to reset. And that just kind of helps you test for that, so that you don't go to do a full punch out right off the line and have it just go desync and fall out of the sky. Also, don't do full punch outs off the line. I hate it when I go and fly with people and they set their quad down 3 feet away from us and then they arm it and go full throttle and launch to the moon. That is horrible, horrible, horrible practice, and you should be shunned. Okay. It's just unsafe. You don't know what it's going to do. I have seen so many times of people who have put a wrong prop on or have something break between flights. Like, there's no reason to put everybody on the flight line in danger. Walk out 10, 20 feet, set it down further away from all of the people, arm it, and take off in a controlled manner. Get 50 feet away from us and then do a full punch out. You know what I just saw, Monkey? I'm finding these things all over the house, you guys. That's a Monkey FPV sticker.
I stickered everywhere.
I know, there's one in there in the guest bathroom on the back of the door. I noticed that one earlier today.
That's so fun.
Okay, so pre-flight inspections. I am bouncing around a little bit, but I felt like it was an adequate time to talk about the pre-flight inspection, because we're getting into the unscheduled maintenance, which is going to be pretty much all of our maintenance. And as I was saying, you just have to inspect the craft, make sure that if you have reason to think that something might not be working properly, like, hey, I keep getting bad video when I, fly in these scenarios. Well, maybe I've smashed that antenna a little bit too much. Go ahead and replace the antenna. And then if that doesn't fix it, go ahead and replace the video transmitter. There's no point in flying around shoddy equipment that's only going to cause you more and more problems. It's another pet peeve of mine when I'm flying with somebody and they're like, how's everything going? Oh, it's flying like crap. It keeps falling out of the sky. Quit flying that thing. It's unreliable and you're going to end up hurting somebody or breaking something else. Like, fly reliable gear. And if it's got a problem, track down the problem by, using logic and reasoning. I should make like a whole course on troubleshooting mini quads, because that's like an art form unto itself that we're not going to get into right here. Okay. They do speak a little bit about performing maintenance. In some instances, you may require maintenance tasks performed by the manufacturer. That's going to be rare. For FPV, there's been a couple times where, like, the goggles may need to be sent back or something like that. But most of our maintenance is going to be conducted by us. However, if the operator decides not to use the manufacturer or personnel recommended by the manufacturer, hang on. It's basically, this section is laying out that you can perform your own maintenance, but that the maintenance should be done by somebody familiar with the UAS and its components, which should be you, because you probably built it. If the operator or the maintenance personnel are unable to repair, modify, or overhaul it back to safe operational specifications, then it's advisable to replace the UAS or the component with one that is in condition for safe operations. Like I was saying, if your ESC keeps desyncing and you fall out of the sky, don't keep flying it. Replace that ESC. I feel like a lot of this is kind of common sense. So let's go back and see what else we got going on in here. Maybe. Okay, that was just the persons that may perform the maintenance. That is you, unless it is something that is outlined by the manufacturer. They actually say this down here. Record keeping. No. Okay. They do get a little bit more in detail about the pre-flight inspections and inspection procedures. For instance, right here, creating an inspection program. An option as a UAS owner or operator may wish to create an inspection program for their UAS. The person creating the inspection program for the UAS may find it sufficient details to assist in the development of a suitable from a variety of. That's just like a whole lot of words that mean nothing. So they give you a list of pre-flight inspection items. I have kind of always approached this from the same with the same mindset of like the way that airlines operated. If I have not had anything, like I didn't have a major crash the last time I flew at Steels, I didn't. I don't expect anything to be bad with it other than just the props. So my inspection is going to be pretty basic. I'm going to spin all the motors, make sure that they're freely spinning, not like all gritty or stuck. The props are in good order, that the arms have not wiggled their way loose, that the top plate is still secured, that my battery straps aren't eaten through. And then, as we said earlier, that I got good video and that the craft reacts to control inputs in the same way. And that is my like everyday inspection procedure. Now, if I have to take off the top plate for any reason, then I do like the next phase of inspection where I like look at the wires, make sure, hey, are any of these wires getting nicks on them? If so, why? Maybe I left the video cable too long and it keeps getting out and getting into the props. Like that would be really bad. But it's just an example. A lot of times I will have, because of the routing that I've chosen for the particular stack of the XT60 cable, be getting prop strikes on the XT60, on the power lead from the ESC to the battery, in which case maybe I need to replace that lead, or maybe I need to solder on a different lead so that it's not getting into those props. It's another thing that I will look at. If I've got the top plate off, I'll also look for any kind of corrosion. Like, has it gotten wet? Is there some kind of corrosion building up that I might need to be concerned about? For instance, the stack that I had to replace, I crashed in water. I did my due diligence and rinsed it off and everything, but it still was getting corroded, and the 5-volt regulator on the flight controller went bad. And when I took it all apart, the ESC also had a lot of corrosion, and so I ended up going ahead and replacing that whole stack because of that. So this is a list of all of the things that could be on in your pre-flight inspection and or a inspection program. I think of mine as more of an inspection program. If I am, like I was saying, I have my everyday or every flight check items. Motors are spinning, props are in good order, battery straps aren't eaten through. Those are all the time. I have, anytime I've done maintenance, all 4 motors spin. Yes, all the, like when I arm, the aircraft reacts to control inputs. Yes, and then I have major maintenance where I'm like replacing things. I'll go through and look and be like, oh, are all these wires in good order, etc. Is there any corrosion? Anything that I should be looking out for? Yeah. So let's look at some of this stuff. Visual condition, visual inspection, airframe structure. Yeah, making sure the arms aren't working their way loose, that you haven't got D-lam in any of your carbon fiber. Make sure that the registration and markings are there. We don't really have movable control surfaces, but if you're talking fixed wing, then yes, that would be something to look into. Servo motors. All of our motors, our propulsion system would be our motors, our ESCs, our props. That is your powertrain. Uh, Control unit, flight controller, getting 5 volts, all of that stuff. Most of this stuff is fully checked in my little arm test and control input test. You could consider that being checked. We don't use a compass, so no need to well, I don't use a compass. No need to calibrate that before flight. Ensure that your control link is good. So I would say that if you are considering making something more organized and more formal than what I do, just as best practices, this would be a great list to base your inspection procedure off of. Okay. And I'm not going to sit here and read every single one of them because it's just redundant. Okay, who can perform maintenance on a UAS? That is going to be the owner, operator, and or builder. And also, there could be times where a manufacturer would require that maintenance to be done by them. But typically, yeah, typically the only way that they're going to be able to absolutely require you to take it to them is they're just going to tell you, oh, if you do that on your own, you're voiding your warranty. you can still do it on your own if you are adequately like knowledgeable and able to do it. Okay. And appropriate record keeping. There's a bit up here on record keeping. I thought there was something in here on record keeping, but I don't think there is now. Yep, there is. Benefits of record keeping. Basically, keeping records of maintenance is a good thing. If you were ever to have an incident where you were to cause bodily harm or something, and they're like, well, what kind of condition is the craft in? If you have a record of all of your ongoing maintenance with the drone, then you would be in a better position to say that it was, you know, that you were adequately maintaining it and not negligent. But yeah, this is just going on to say that it's good to keep good records. That ought to do it. Man, this one covers so much. I don't think that I could go over everything that I know about this in one. It says techniques to mitigate mechanical failures of all elements used in a UAS operation, such as the battery and or devices to operate the UAS. Like, I could go on for 30 minutes talking about antenna placement and where to put your antennas so that they are least likely to get damaged, and like frame design on how to design a frame that's not going to break, and frame design on how to design motor protectors to best protect motors, and the types of crashes that you can actually protect a motor from, and the types of crashes where the motor is just going to get destroyed regardless of what frame you have. Yeah, a lot of this is just going to come down to user experience. I don't think that it's this. Dude, you keep jumping up here with your claws and you're killing me. What is going on? You stressing out? Is that what it is? I'm gonna have to put you right back down though. I'm busy. Okay. And with that, that is pretty much everything that we're going to be going over tonight for the maintenance and emergency procedures and weight and balance. So we're going to go and do some practice questions about all of those. Does anybody have any questions at this point? Yeah. King Schools, that's the one I like. I'm going to leave it with just loading and performance for the first round tonight, and then we'll get back into it. Okay. What could be a consequence of operating a small unmanned aircraft above its maximum allowable weight? One of those would be shorter endurance, because you're definitely not going to get faster speed because it's heavier than is recommended. You're definitely not going to get increased maneuverability. As you increase the weight, that's only going to reduce maneuverability because you have more inertia to overcome to either stop or accelerate or change direction. It's kind of just common sense there. What effect does high density altitude have on the efficiency of an unmanned aircraft propeller? Now, we talked about this earlier. We've talked about density altitude and what that is. Basically, that's saying that on a standard day, you would find the density of air that we currently have, wherever we're measuring that air, at an altitude of X, like 2,000 feet or whatever it is. So a higher density altitude is actually less dense air. So, and propeller efficiency decreases with less dense air or higher density altitude. Density altitude does not affect propeller efficiency. That's just false. And propeller efficiency does not increase with higher density altitudes. It's so like backwards. Monkey, if you are interested, you should go and consult the weather thing on to find out about density altitude and how it's calculated and what all it means. Anybody else that's not in here every week too. All right, operating outside of the weight and balance limits of an unmanned aircraft can result in loss of control of the aircraft. Um, like it's possible to operate an aircraft outside of its weight and balance limits. It's just not going to be a safe thing. It's definitely not going to increase in performance. It could result in loss of control. Refer to figure 2. Okay. Oh, see, I forgot that they had these questions. So what this, I'm just going to describe this right here. Let me remove me so that you can better see it. All right. And what this it is a graph that shows the the angle of bank and load factor. Now, load factor is measured in G's. 1 G is 1 times the gravitational force of the Earth. So right now you're feeling 1 G. If you've ever ridden a roller coaster, then you've probably experienced like 2, maybe 3 Gs, where you know if you go through the like down part, you feel really heavy. Those are increased Gs. When you go on the like top of the roller coaster where you get weightless, that's less than 1 G. Now, whenever you are flying a like a fixed wing plane and you just go into a constant angle of bank turn, the craft goes under a load factor, which is an increase. And this graph slash collection of data is just showing you that. So at 10 degrees of angle of bank, we experience 1.015 G. To get to 2 Gs, you have to be flying at 60-degree angle of bank, and you're pulling 2 Gs. At 90 degrees of bank, you would have infinity G's. That's funny. But you get the idea. It goes up exponentially as you increase the angle of bank. The number of G's that you're pulling increases. Obviously, with mini quads, it's not quite so what's the word I'm looking for? It's not quite so straightforward because I can fly at like a 45 degrees of bank, and because I don't have any throttle, it would just be falling out of the sky and it would be having 0 Gs. So we kind of have a little bit different. If I could have a bank like this and be full throttle and be pulling like 12 Gs, etc. So this is really more geared towards fixed wing, but as a 107 operator, you could be operating fixed wing drones. Buddy, I need you to like chill for like another hour or so. Okay, if an unmanned aircraft weighs 45 pounds, what approximate weight would the aircraft structure be required to support during a 45-degree bank turn while maintaining altitude? So what you're going to do is you're going to come down here and look at 45 degrees. The load factor is 1.414. You're going to multiply that times the weight that they give you of 45 pounds. So 45 times 1.41, I'm guessing it's going to be 63, but let's ask Alexa. Alexa, what is 1.414 times 45?
1.414 times 45 is
63.63. So 63 pounds. There's your answer. Take a calculator with you to your written exam. Or Alexa. I think they might see that as cheating, though. Which combination of atmospheric conditions will reduce? That's a good note, though. Don't go in expecting to be able to use your cell phone as your calculator on this on your 107 written exam. It's a good idea to take a basic calculator or just be good at handwritten math because they'll let you have a pencil and scratch paper. So yeah, take like a basic calculator in with you because you are allowed to use one of those. You're not allowed to use your cell phone. All right. Which combination of atmospheric conditions will reduce aircraft takeoff and climb performance? All right, so we're talking about what will increase, or no, what will reduce aircraft climb and takeoff performance. So things that reduce performance are going to be high temperature. So we've already ruled out A. It can't be A, even though I clicked it. A high density altitude is going to also reduce the performance, as we discussed earlier. The higher the altitude, the less dense the air, the less the performance. And I didn't even have to take a guess on humidity. It's actually going to be high. I did know that one. I just, yeah. The other two are more like just I feel like to me at this point they're like common sense. You get a higher temperature, you end up with higher density altitude. If you have because the density altitude is pressure altitude corrected for non-standard temperature, um, and so both of those, the high temperature and high density altitude, are just like intuitive for me at this point. Whatever. What are the four forces that act on a plane in equilibrium? I feel like this is a good thing to do a little drawing on because I didn't really talk about this in depth. I should have done better on the performance. But we'll make a drawing so that we have, and just take a minute to talk. New, do the default, create that ish. And I got my brush. So here we go. We got a little plane. God, that is a janky wing. All right, so pretend like my plane is not as jank as it really is. And in flight, you have four forces that act on that plane. So we have our thrust, which is like this. We have gravity, which pulls us down. We have lift that is generated by the wing. And we have drag. There's two types of drag. There is induced drag, which is drag that is caused by the generation of lift. And we have parasite drag. And parasite drag is drag that is from things dangling off the airplane. So like landing gear creates parasite drag, wings create induced drag. So in straight level unaccelerated flight, these things all equal out. Your thrust will be exactly equal to your drag. Your lift will be exactly equal to your lift will be exactly equal to gravity. So in straight and level flight, all four forces are in equilibrium. So during unaccelerated flight, unaccelerated level flight. This is one thing that I feel like is a good thing to discuss though for mini quads because it's something that I feel like gets over. Oops, that's not what I want. Where's the erase thing? This like shows how poorly versed in. Oh, that's the problem. Okay. My erase was set with the wrong colors, or my palette, whatever. You get the idea. Okay, so our mini quads. I'm gonna see if I can't draw a mini quad in. It's just the normal. There we go. So we have a drone here, some spinning props on the top, and it's got a whole box. This is like a horribly drawn drone. I grant you that. But I just want to illustrate this. Does everybody kind of see, like you'd have a GoPro up here looking straight forward as it's going, and it's got a little lens on it. So just ignore my horrible drawings for a second and bear with me. So mini quads are a little bit different than a fixed wing plane, but I feel like this is something that everybody that flies FPV can benefit from. Your mini quad is generating its thrust just like this. And so it still has those two of those other forces are always the same. So this is your drag. It's going to be just like drag on a fixed wing plane, except we don't have the same aspect of induced drag because we're not generating our lift. I guess you would have some induced drag from the propellers, but let's not get into that. Mostly we're dealing with parasite drag because we got this big old bulky GoPro out in front and just like a big brick strapped to the front of the craft. And we also have gravity acting on it, right? Now, one thing to note, if you've ever taken trigonometry, I'm just going to select a different color here for this little bit. This is a problem of where you can break this down and you're creating a right angle triangle and you could mathematically solve for these, but there are two components here. One, on this side, part of that thrust that the quad is generating, this is your lift. That is what's keeping the craft from climbing or descending. This is you can think of as your thrust, right? What is pulling you through the air to counteract that drag? Okay, I can't write with the brush tool very well. You get the idea. That's an S, I swear. That could be considered your thrust. What is going to pull you forward and either cause you to accelerate or decelerate. Now, if you've flown FPV for any length of time, then you have some intuitive understanding of this. If you want to go faster and not climb, what do? You tilt further forward so that your thrust vector is pointed more forward and is going to accelerate you more until the drag increases to a point that you're not accelerating. Now, when you tilt forward, what do? You have to increase the amount of throttle that you're giving it, because as you tilt this thrust vector further forward, you get a smaller portion of that thrust being generating lift, and a greater amount of that thrust pulling you forward through the air. I think thrust is a bad word that I've chosen here. Horizontal component of lift. How about that? See, so in order to compensate for the loss of lift that you're giving it more thrust to keep you at the same altitude. In the same way that if you're coming out of a dive and you realize, hey, I don't have enough power to pull out of this, because you're like looking forward and you're trying to accelerate forward, what do? You flatten out so that all of your thrust is being generated into lift to arrest that downward motion. So that, I feel like this is having a basic understanding of the thrust on a mini quad and how it translates to a horizontal and vertical component of thrust, and the forces that you're compensating for being gravity and drag. Like it's a good thing to wrap your head around, because as you start to run into problems of like, hey, I'm not able to do this maneuver or power loops, to sit there and think about, all right, when I see this, my thrust vector is pointed this way and is causing the craft to do this. Or maybe, I don't know, anytime that I'm having trouble with a maneuver, I start sitting there and thinking about, all right, what's happening with the thrust vector? How can I make it do what I want it to do? Because ultimately, that's all a mini quad is you have the ability to decide what direction to point your thrust vector and how big of a thrust vector you want it to be. And everything else is just like a result of that. So if you can't do something with a mini quad, it's probably because you don't understand where your thrust vector is pointed and how strong it should be at that time, like, or where it should be at that time. Yeah. Okay. Back to our questions. Just dropping some knowledge on you. All right. Refer to Figure 2. If an unmanned you're probably gonna see one of these questions on your written exam. So, unmanned aircraft weighs 20 pounds, and we're in a 60-degree bank. What weight would the drone have to be supporting? Anybody want to take a stab at this one? I kind of showed you how we do it.
40.
Nailed it. Does everybody understand how we got to 40? Basically, what we did is we're doing a 60-degree bank, which means we come down here to our angle of bank. You can either use the graph or this table of data. I feel like the table's a little bit easier to read. So 60-degree angle of bank means that our load factor is 2, so we can multiply our load factor times our weight of 20, and that gives us 40 pounds of the total load. All right, the term angle of attack. I've gone over this one before. Can anybody just answer this off the top of their head? If not, I'm going to explain it again.
For airplanes, the angle of attack is the difference between how the wing corresponds to like the incoming force, kind of.
That is absolutely correct. Now, could you look at these possible answers and get it? Okay, so the problem is you have a basic understanding of what the angle of attack is, which is great, but there's two answers here that could be accurate, because the airplane center line, the angle between the center line and the relative wind, would fall under your definition that you just gave, which is good, is a good basic understanding, or the chord line of the wing and the relative wind, or the airplane's longitudinal axis and that the air is striking the airfoil. So all three of these are basically saying the same thing that you just said. The difference is just knowing all of the right terms. So I'm just gonna go back to my Photoshop thing real quick and give you guys a little sketch again. I like my whiteboard. I should probably start out with creating a whiteboard before the stream every night so I don't have to wait on Photoshop to boot up. Okay, so here we have, I'm just going to keep working in red. So this is an airfoil, and I drew it like this because the plane is at a steep angle of attack and flying, right? So it's flying along, and the wind is coming straight forward from the front. Now, the one thing to note is the chord line. I've already given away the actual answer. The chord line is the line that goes from the leading edge of the wing to the trailing edge of the wing. It's an imaginary line, but it is used to determine your angle of attack, which is the angle between the chord line of the wing and the relative wind. Now, relative wind can, like, if you see a plane that's flying like this, you think, oh, the wind's coming at it like this, but that's not necessarily true because the plane could be climbing, which would affect that angle, that relative wind, or it could be descending at that high angle, which could increase the angle of attack because the relative wind would be coming from above or below in those various scenarios. But the important angle is the angle between the chord line of the wing and the relative wind. So it's just an exercise in vocabulary. You had an understanding of what we're talking about, though.
Nice, perfect. I would say.
Yep. 4 forces acting on an airplane in flight are, anybody want to take a stab?
Lift, weight, thrust, and drag.
Wait. Yes. Weight, gravity, whatever. Okay. Lift, weight, thrust, and drag. Yeah, because B has weight and gravity, which we've left out drag. C, power and friction. Those are, like, yeah, just not good words. Lift, weight, thrust, and drag. I was doing you guys a disservice by talking about gravity in my explanations earlier. Apologies. All right, what effect, if any, does high humidity have on aircraft performance? We kind of touched on this on an earlier question. Does anybody remember? Kitty, don't jump on me. You're going to, like, claw me again. It decreases. It does. It decreases performance. And I'm clicking on the OBS and not the browser. And submit. And we got 100. Yay. Let's do another 10 on just weight and balance of performance. And then we'll open it up to some more sections of the written exam. All right. To ensure that the unmanned aircraft's center of gravity limits are not exceeded, follow the aircraft loading instructions specified in the pilot's operating handbook or UAS flight manual. The aeronautical information manual is just general information for pilots. There is no aircraft weight and balance handbook. Unfortunately, we don't have pilots operating handbooks or UAS flight manuals because we're dealing with straight home builds, not fancy things. Okay. Which combination of atmospheric conditions will reduce aircraft takeoff and climb performance? We had this one last time. Anybody?
C.
That is correct. High temperature, high relative humidity, and high density altitude. Which statement relates? Oh, Bernoulli. You know, I kind of talked about this in a previous stream about principles of flight and lift. So Bernoulli's principle has... I just want to explain it. Let me talk. I'm just kidding. So basically, Bernoulli's principle is that if you have it's a law of fluid dynamics. If you have and air acts as a fluid, for the purposes of this. So you have two particles of air that meet at the front of the leading edge of a wing. One goes over the top of the wing, one goes underneath. They have to meet back up at the trailing edge of the wing, just like they were at the leading edge. But you can see that the particle that goes over the top has a longer distance to travel than the particle that goes underneath, meaning that it will have to go faster. And according to Bernoulli's principle, if you accelerate a fluid, the pressure decreases. So because the air going over the top of the wing is accelerated, the pressure is decreased on the top of the wing, creating a pressure differential where you have higher pressure under the wing than above the wing, which generates lift. So that is what we're talking about when we talk about Bernoulli here. And which statement relates to Bernoulli? Somebody said C already, correct?
Yeah.
Yep. Air traveling faster over the curved upper surface of an airfoil causes lower pressure on the top surface. The angle between the chord line of an airfoil and the relative wind is known as angle of attack. The angle of incidence, let's just talk about that real quick. The angle of incidence is the angle of the chord line to the longitudinal axis of the plane. If you, I've lost what I'm looking at as my actual mouse. I just want to explain this in case you guys get a question on it. Where's my eraser? There it be. So the plane sitting on the ground, we got like the main landing gear and a nose gear. I'm going to test my drawing skills. Propeller there, and we have a wing that is mounted on this bad boy, right? And so we have our chord line of the wing, and we have our longitudinal axis of the plane. This is the angle of incidence. And now you know what angle of incidence versus angle of attack is. There is no angle of lift. That's just malarkey. All right, when are the four forces that act on an airplane in equilibrium? They are in equilibrium during unaccelerated flight. At what bank angle for a turn does the additional force of the wings become significant? This is just going to be 15 degrees. If you see, do we have another question? No. Crap, actually, I think the answer is actually 30 degrees. At 15 degrees, we're still like at 1.1, 1.3. At 30 degrees, we're getting up towards 1.5, 45, or no. Oh man, I may be wrong on this one. It may be 45. We're gonna go with 30. That's gonna be my final answer.
Like 60 is 2 times, right?
Yeah, 60 is 2 times. 60 is definitely significant. It may be 45 that they're looking for here because 45 degrees of bank and higher are considered steep turns, which is a maneuver that you have to do for your private pilot exam. Yeah, I'm going to stay with 30 and probably get it wrong. The amount of excess load that can be imposed on the wing of the airplane depends on the amount of excess load. It depends on the... I mean, I would say that none of these would be the answer that I was looking for on a full-scale written question. I'd be looking for the category of the plane because that dictates what kind of wing loading it can take. See, this, I guess it's going to say speed of the plane because they're probably referring to the lift equations, the things that affect lift. The lift equation is lift is equal to the coefficient of lift, which is a function of your angle of attack, times the wing area times the speed, and squared. So I'm going to say that it's the speed of the aircraft because the faster it's going, the more it has a higher ability to generate lift. I'm going to be real upset if I'm wrong on this. Because the abruptness that it's applied isn't going to change anything. The position of the CG, while it could affect it, in certain scenarios, it's more universal to say speed of the plane. What could be a consequence of operating a small unmanned aircraft above its maximum allowable weight? Your shorter endurance. Center of gravity can be found by dividing the total weight by the total moment. We did not do any, they don't have you do any example weight and balance calculations, and I chose not to teach you how to do weight and balance on fixed wing. Where's my thing? Turned me off. There we go. Under what conditions is pressure altitude and density altitude the same value? Pressure altitude and density altitude are the same at standard temperature because density altitude is pressure altitude corrected for non-standard temperature. So if we have standard temperature, then pressure altitude and density altitude are the same. Submit 80%. I guarantee you the angle of bank. Yep, it was 45 degrees. So mental note, the angle of bank at which additional forces on the wings become significant is 45 degrees. Oh man, I got it backwards, dividing the total moment by the total weight. It's also been like an absurdly long time since I did weight and balance calculations for a aircraft. Let's just look here real quick since I feel like I'm like short selling you. This is what an example of calculating the weight and balance on a plane would be. So they would give you these numbers here. So you have the plane's empty weight and arm and moment would be provided to you. The oil and its equivalent arm and moment. Did I do an adequate job of explaining the arm to you guys earlier? I don't think I did. Let's go back to our drawing. So here's our plane. And for this given plane, there would be a datum plane, which could be out in front of the plane. It could be right here. It's just an artificial point. Keep going back. Oh no. Crap. I forgot that that's like a shortcut for this. How do I? Okay. So it's just a point that is decided upon. So we'll say that this is our datum plane. And so for the front seat, you would take a measurement of the front seat to here, and you would measure that distance, and that is your arm. The moment would be the weight of my big old fat butt times that arm would give us the moment. So then you would consult your data here. Wait, where did I go with this? So your pilot seat, 170 pounds, times the arm would give you the moment for that. So you would have to go through and fill out the data for the pilot, the passenger, your baggage, your fuel, and you would need to know that fuel, that avgas is 6 pounds per gallon. There's not going to be a question like this on your written exam, just so that you know. And you would multiply the weight times the arm, which would be given to you for a given plane to get the moment, and then you'd add up all of your weights and all of your moments, and if you divide the total moment by the total weight, that will give you the arm, or where your CG is measured in inches aft of your datum plane. Does that make sense on how they're calculating the center of gravity for full-scale planes? Because with a full-scale plane, you can't sit there and hold it and make sure that it balances like at the center point of the wing, like you would if you're building like a model plane. That you're just going to hold it and be like, oh yeah, that's good, we're good to go. With a plane, you can't do that. You have to calculate it prior to the flight. And I guess at some point with a UAS, no, you can't, because you guys aren't licensed to fly them over 55 pounds. You should always be able to lift it and figure out where the balance point is. So I feel like this is a little dumb. But I'm not going to get into my biases. Let's do one section of 20 questions where we're going to let it throw everything at us. Because the only thing that we haven't covered are aeronautical decision making and physiology. Oh, what? The only sections that we haven't gone over at this point are physiology and aeronautical decision making. So we're going to just do one round of 20 questions. I know we got a couple of new guys that weren't here for all of the previous streams. And don't worry, guys, you can go back and watch the old streams. They're still available. All of the links are in the past 107 streams section on Discord, as well as the Patreon has a list of all the posts that I've made that are 107 specific, so that you can go and look at those. But after next week's stream, so we'll do that next week, and then the week after that, we'll go over applying for and obtaining waivers. And then I'm going to start right back in, and but this time around, I'm going to have full-on PowerPoints because I'm doing the PowerPoints for my first responders training here in November. So we'll do it a second time around with better graphics and a better lesson plan. All right, here we go. Let's just jump into these questions. All right, what conditions are necessary for the formation of thunderstorms? We have to have high humidity. Actually, yeah. You don't need extensive cloud cover, so that one's ruled out. We need the high humidity. We don't have to have high temperature, but we do need lifting force and unstable conditions. If you remember, if you have stable conditions and you get a lifting force, it'll just like quit going up. But if it's unstable, it keeps going up, and that lifting action will make you a thunderstorm. What action should a remote pilot take when operating in a military operations area? Exercise extreme caution when military activity is being conducted. Operations in a MOA or military operations area are not prohibited. And where do you find out if it's active? You go to the borders of your sectional chart. I forget what they call that. Crap. Just drawing a blank. Basically, around the border, there's a section that shows you look on the chart, you see the MOA, and then you go to the border and look under that name for the MOA, and it'll tell you the hours of operation, the altitude of it, and the controlling agency. Okay. A temperature inversion would most likely result in which weather condition? Definitely not this. It would be poor visibility or extensive cloud coverage low. It's not clouds with extensive vertical development, because that temperature inversion is going to preclude vertical development. A temperature inversion would be a temperature increase as altitude is increased. That is the definition of a temperature inversion. So C is your answer. The correct method of stating this altitude to ATC is 10,500 feet. Not 10.5, not 10,000. Wait. Shit. It's 10,500. Look at me. See, this is where it gets to, like, at airline operators, when you fly so much, you start figuring out ways to say things shorter. 10,500 is the proper way to say it. Now, if I was checking in with somebody with Atlanta Center or Atlanta Departure, I'd be like, AC 5140, checking in with you 10.5 for 12. Because I'm going to make it short. I hate these questions. But the correct way of stating it is 10,500. The longest possible way. Refer to figure 75, area 6. During pre-flight planning, you plan to operate in R2305. Where would you find additional information regarding this airspace? So area 6 down here, R2304. So this is a restricted area. And as we stated before, it's going to be in the margins of your sectional chart. But that is the special use area of the chart. There, that's the proper name for it that I was drawing a blank for. The Aeronautical Information Manual just has all sorts of information about like airport markings, flag signals, phonetic alphabet, all of that stuff. The chart supplements is going to tell you where to get gas at an airport, have a little diagram for it, hours of operation of the tower, all of that stuff. We've talked about all that though. The numbers 8 and 26 on the approach ends of the runway indicate the runway is oriented approximately. Anybody want to take a stab at this one?
B.
So close.
Or no, C. It's magnetic.
It is magnetic. The runways are named for their magnetic heading, and it's funny because the magnetic north moves. They just announced that it moved. I just heard something on NPR the other day where they're like, the magnetic pole has moved in this direction for the first time in blah 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 years. Every year they have to update the magnetic variation, which is the angle between magnetic north and true north, and yeah, and so sometimes that angle changes enough that they have to rename airports. Like, it wasn't that long ago that like a bunch of the airports on the East Coast had to change their runway identifier. It's interesting. Anyways, an unmanned aircraft has been loaded in such a manner that the CG is located aft of the aft CG limit. One undesirable flight characteristic a remote pilot might experience with this aircraft would be difficulty in recovering from a stalled condition. It's not going to increase your takeoff run because you're still generating the same amount of lift. You still need to acquire the same airspeed in order to get off of the runway. You're still going to stall at the same angle of attack. The stalling of an aircraft is predicated on the angle of attack. It's not actually on the airspeed. It's kind of a common misconception. You can stall at any speed just as long as you get that angle. Like, if you abruptly pull back on the stick of a fixed wing plane, you can cause it to stall even when it's going really fast. So, but the recovery from a stalled condition, because normally when you stall an aircraft, you quit generating lift, and if the center of gravity is forward of that center of lift, the nose will drop, you pick up airspeed, and then you recover. If your center of gravity is too far back, when it stalls, it'll just start mushing down and not recover on its own. Yeah, you might have to do more, and if you don't have enough air flowing over the horizontal stabilizer and elevator, you may not be able to aerodynamically lower the nose. Okay. Pilots flying over a national wildlife refuge are requested to fly, does anyone remember? No lower than... It's no lower than 2,000 feet AGL, which, if you know anything about 107, you can't fly above 400 feet AGL. So what does that tell you? Don't fly over national wildlife refuges. What measurement can be used to determine the stability of the atmosphere? I feel like this is one that we have not gotten before in the on our weather days or other days. But the way that they actually measure the stability of the atmosphere is by comparing the actual lapse rate, meaning as you go up in altitude, what the temperature is, and you're like, okay, it's actually cooling off at 3 degrees per 1,000 feet, or 1 degree per 1,000 feet. And what they do is they measure the actual lapse rate and compare that to the standard lapse rate, and that's how they determine the stability of the atmosphere. So, the measurement to determine the stability of the atmosphere, actual lapse rate. The lateral dimensions of Class D airspace are based on, it's just 5 statute miles from the geographical center of the primary airport. That's it. Class D airspace always looks like a soup can. 5 miles around the center of the airport. Boom. In weight and balance calculations, the arm is the distance from the datum line to the item. Okay. One in-flight condition necessary for structural icing to form is a small temperature dew point spread. Again, you're not going to be operating in conditions for icing. Just not, because it's not going to be a pretty day to go fly. Which weather conditions should be expected beneath a low-level temperature inversion when the relative humidity is high? Below a low-level temperature inversion, you're going to have smooth air, poor visibility, fog, haze, and or low clouds, because you're not going to get any lifting action. You're not going to be able to get above that low-level inversion. It's just going to hold a bunch of dusty, moist air down low. If the remote PIC refuses to submit to a blood alcohol test when requested by law enforcement, that is grounds for suspension or revocation of their remote pilot certificate. And yep, you can't wait. There's no option for a delay, and there are definitely consequences to the remote pilot. So the other two answers are obviously wrong. Under which conditions will pressure altitude be equal to true altitude? Anybody want to take a guess? It is when standard atmospheric conditions exist, because pressure altitude is the altitude at which you would find the current pressure you're experiencing on a standard day. So if the standard atmospheric conditions exist, then pressure altitude and true altitude are the same thing, because they just do such a counterintuitive way of measuring pressure and density by giving it to you in altitude figures. I feel like it's a disservice to themselves. Refer to figure 12. What are the wind conditions at Wink, Texas? Wink, Texas, INK. This is a METAR. If you're just joining us for the first time, this is the identifier, the airport that it is. Refer to our weather stream if you want to get a better breakdown. It's taken on the 12th of the month at 1845 Zulu. Winds are 110 at 12, gusting to 18. So that's 110 degrees at 12 knots, gusting to 18. All right, refer to figure 22, area 3. Area 3, right here. It's going to be about that airway. The vertical limits of that portion of Class E airspace designated as a federal airway over McGee Airport are, okay, so it has to be in Class E. Oh wait, no. The vertical limits of that portion of the Class E airspace designated as a federal airway over McGee. It can, all right, so the Class E ends at 18,000 feet where we get into Class A. Airspace. So it is not A as an answer because that airway goes up to 17,999. So we need to know what altitude, and it's not going to be this one. I can tell you right now it's C because we're going 1200 AGL up to the Class E airspace is, unless we're within the shaded magenta area, meaning that the Class E comes down to 700 feet above ground level, or inside of a dashed magenta like this one, meaning that the Class E comes all the way to the surface. So you have Class G from the surface up to 1200 feet AGL, because we're not in any of those shaded areas. And then from 1200 AGL to 18,000 feet, we have Class E. So, did I thoroughly confuse you on that question? I would say consult the airspace stream, but I did explain that in a really bad way, even if you understand basics of airspace. The question is asking you, what are the vertical limits of the Class E airspace in that in this federal airway right here? Yeah, because it's not McGee. Why is it asking about the airport though? Over McGee Airport. An identifier for it. I feel like if the question was about one of these airports. Oh wait, there it is. McGee. Yep. So we're definitely not in the shaded or the dash magenta line. So the E airspace here is from 1200 AGL to 18,000 feet. And that is our question and answer. Uncontrolled airspace is Class G airspace. That is the only uncontrolled airspace. Classes E, C, D, and A. Wait. Classes B, C, D, A, and E are all controlled. That is not alphabetical order. Refer to figure 15. During the period of time 0600 Zulu to 800 Zulu, what visibility is forecast for Oklahoma City? So we come down here. This is a TAF, or Terminal Aerodrome Forecast. We got Oklahoma City. The measurement is taken on the 5th of the month at 11:30 Zulu. This TAF is valid from the 5th of the month at 1200 Zulu to the 6th of the month at 1800 Zulu. But we're only interested in the times of 600 to 800 Zulu. And I know that that's near the end, so I'm going to come down here. See, this is a probability from the 6th of the month at 00 Zulu to the 6th of the month at 06 Zulu. Go all the way over here to becoming from the 6th of the month at 600 Zulu to the 6th of the month at 800 Zulu. These are our conditions. And it's asking about visibility. That's going to be this little section of information here. That P is for greater than. So it's greater than 6 statute miles. All right. What weather is forecast for the Florida area just ahead of the stationary front? Again, I hate this question because there is no ahead of a stationary front. Stationary front's not moving. But this is a stationary front because it's alternating blue, red here. The area around our stationary front is inside of the green with the dashes, which it tells us that right, let's see what are our options. Sorry, I'm like struggling to read the teeny tiny font over. I should just look at this screen because it's bigger over here. So this has to do with the freezing level. This has to do with rain. The blue with the bubbly is this, and that is ceiling 1,000 to 3,000 feet and visibility 3 to 5 statute miles. So 1,000 to 3,000 feet and or visibility 3 to 5 miles, and continuous precipitation, which is given to us down here. Our precipitation. Oh wait, no, shit. So this this arrow is giving us intermittent precipitation. Yeah, it's going to be intermittent. Where's the intermittent one? Ceiling 1,000 to 3,000 feet, visibility 3 to 5 miles with intermittent precipitation. The way that I'm getting the precipitation is from these blue dots and dashes. So, yeah. Where's a good breakdown of these? Consult with the weather stream for better information on that. Let's grade it and see how I did. Don't be wrong. Oh, got wrong ones. I feel like this is one of those that I feel like I always get wrong, is that the lateral dimensions of Class D airspace. I feel like sometimes I think I go with the instrument procedures and then I'm wrong, and sometimes I go with the 5 miles and then I'm wrong. The answer was the instrument procedures for that airspace. In-flight condition necessary for structural icing to form. Visible moisture. If you have if the temperature dew point spread is low, you can also have icing. I disagree. I want to argue that. But the important thing is that we are. Oh God, I knew I was going to be wrong on that. I don't look at those charts enough, and I always forget the dots and the dashes. That's why I was like, consult the weather stream, because we went over it in the Airman's in this document here, our Pilot's Handbook of Aeronautical Information. If you come over here to Aviation Weather Sources, you will get a breakdown for your prognostic charts and what all of those symbols mean, which we did go over, but it has just slipped my mind because that is not something that I use on a daily basis. Apologies. I'm like, these many dots means this? No, you're wrong. All right. Apologies. Anybody got any questions before I bounce out tonight?
Should have did it behind your back.
Oh my God. Yeah, that would have been more impressive, right? if I had done the whole stream behind my back. You know, it's funny. I really, the whole reason that I flew, it wasn't something I planned on doing. It was just that Steele wouldn't point the damn camera away from the radio. And so I put the radio behind my back and I was like, screw it. If you're not going to move the camera, I'll just keep it behind my back and go fly instead of dragging this on forever. And it ended up being a thing. I didn't realize that I was going to be as good at flying with a radio behind my back as I was.
Actually, never. No one there yet.
Yeah, everybody, as soon as I took off, they thought I was going to kill him. Meanwhile, I just started going and power looping everything.
That's right.
It was epic, no doubt about it.
I appreciate it. Goodness. All right, well, does anybody have anything else they want to chat about before I hop off here?
I was gonna say I live in a Class D airspace that's actually not a soup can.
Really?
They've actually, yeah.
Where? What?
I can send you the link for it.
What airport is it?
It's Selfridge Air National Guard.
Do you know what the aeronautical identifier is for it?
MTC? No. I'm looking at the what is it? VFR map.
Yeah, I got the sectional over here. Selfridge, got it. Well, that's Selfridge Vortec. No. Oh wait, maybe if I zoom in. Okay, there we go. Selfridge. That is a Class D airspace that is not a perfect soup can. You are correct. They do exist. All right, well, I've been corrected.
Yeah, the bane of my flying experience.
So wait, are you a full-scale certified pilot?
No.
Okay.
I had worked towards it a long time ago. But no, I can't fly in my backyard. I've actually got to drive a couple miles away from the house in order to fly.
Have you checked to see if you're in the Lance system?
It is coming soon is what AirMap always says.
Gotcha. Yeah, there's a couple of the airports in the Atlanta area that are not available. Most of them are, but there's still a couple that aren't available in Lance just yet.
Yeah, but you know, researching for my 107, I realized during holidays I can fly, and during you know, certain hours at night based on UTC, and I can't remember what it was, but it's middle of the night. It's not class or rated as Class D, so I could fly.
Oh, yeah, if you get your 107 and a night waiver, that is.
Yeah.
Yeah.
Hence why I'm here.
Awesome. Yeah, well, we'll get you there. I think, so I would suggest, I know that you just recently signed up, just if you want to, you can go through and watch all of the old streams, and then you would have gotten all of the material as of next week for the 107. Or you can just keep hanging out on the weekly streams, because I'm going to go through everything over again. But next week, we're going to do the physiology and aeronautical decision making, crew resource management, all of that. And then the week after, I'm going to show everybody what it takes to get your nighttime waiver, because it's like the easiest waiver. Like, you can literally copy and paste somebody else's application, which is what I did, with some minor changes, and then get your nighttime waiver that way. So it's a really easy waiver to get, and I will be showing you guys how to do it in like 2 weeks. So
excellent.
All right, well, I'm going to go ahead and hop offline at this point, but I'll be back this Sunday for a Popcorn and Props for sure, so come by, hang out, have a good time, have some beers, and then next Thursday I'll see you back here, same time, same place.
Great. See ya.
All right, guys, have a good night. Bye.
Sounds great. Take care.
And